Warning: some viewers may find the following video disturbing. Viewer discretion is advised.
Bum
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 bum.
bum.
Welcome to JFlex Classrooms. I'm your host, Jay Reynolds Nin Jr., and today I'll be teaching you nuclear physics with my co-host, Calvin Chow Chen.
I have a degree in cosmetology.
Thanks, Chen. But before we start off the lesson, let's review. Atoms are the building blocks of all matter. Everything you can see, feel, and touch is all made up of atoms. There are even things you cannot see, feel, hear, or touch that are also made up of atoms. Basically, everything is made up of atoms. Atoms contain three subatomic particles called protons, neutrons, and electrons. The protons and neutrons are found in the nucleus at the center of the atom. The electrons are arranged in energy levels around the nucleus. Protons have a positive charge, while electrons have a negative charge. Neutrons, on the other hand, have a neutral charge, meaning they have no charge. Each stable atom has the same amount of protons and electrons. The chemical properties of an element are determined by the outer electrons. Isotopes, on the other hand, are these same atoms, but with different amounts of neutrons, changing their atomic masses, but not chemical properties. They're a radioactive form of an element. But how does this all tie in with nuclear physics?
That's my question to answer. As the name implies, it deals with the model mechanics of the nucleus. As an unstable atom tries to reach a stable form, energy and matter are released from the nucleus. This spontaneous change in the nucleus is called radioactive decay. In the process, they will release energy and matter from the nucleus, and often transform into a new element. This process, called transmutation, is the change of one element into another as a result of changes within the nucleus. There are three types of radioactive decay: alpha, beta, and gamma. Alpha and beta decay change one element into another. Gamma decay does not. These particles varies when it comes to penetration. For example, alpha particles can be completely stopped by a sheet of paper. Beta particles can be stopped by aluminum shielding. Gamma rays can only be reduced by much more substantial mass, such as a very thick layer of lead. Now moving on to Half-Life. It's an amazing game developed by the company Valve, where you play as Gordon Freeman, a theoretical physicist who is forced to defend himself and the human race against hostile aliens and other enemies following an experiment gone wrong.
Wait! Dr. Chow Chen, I don't think that has to do anything with nuclear physics. I think you're talking about the wrong type of half-life. The term half-life describes the amount of time needed for half of a sample of unstable atoms or particles to undergo decay. The other half of the atoms is transformed into another element. The radioactive decay of nuclei is based on a probability. Within any given time period, a particular unstable nucleus has a fixed probability of decay. This results in the buildup of decay products. The decay products themselves decay into other elements, and a whole host of radioactive materials come into being. Half-life has many uses in science. For example, scientists can use the half-life of carbon-14 to determine the approximate age of organic objects less than 40,000 years old. Furthermore,
Okay, I think that's enough drizzle. Moving on, when discussing the contents of nuclear physics, size will play a huge role as it is a common characteristic many particles share. We all know that particles can get pretty small, but for how small? That's a question for our team of specialists to answer.
Hi, I'm marine biologist Christopher J.P. Felselman, and I'm an expert when it comes to sizes. Scientists first thought that an atom was the smallest thing in the universe, and it was thought indivisible, until it was split to reveal protons, neutrons, and electrons inside. These two seem like fundamental particles before scientists discovered that protons and neutrons are made up of three quarks each. A quark is one of two currently recognized groups of fundamental particles, which are subatomic, indivisible particles as far as we know today that represent the smallest known units of matter. Quarks are so small that even scientists can't conclude what their size actually is. But for other subatomic groups that make up an atom, that's a question for another specialist.
Hi, I'm Physical Education Director Matthew Triple D Dong here, and I'm no stranger when it comes to groups. As you previously heard from Mr. Dr. Falsome, quarks are subatomic particles we know of today, other than protons, neutrons, and electrons. Subatomic particles are constantly being discovered today. Some notable particles would be photons, neutrinos, and Higgs bosons. Photons are particles that make up light. Neutrons are lightweight particles that just barely interact with matter at all. Lastly, Higgs bosons are particles which helps gives mass to elementary particles that have mass, such as electrons and protons. Overall, particles physics and nuclear physics studies these particles and how they interact.
Whoa. Hold it right there, Triple D. Let me take it from here. This lesson was made possible with Dollar Shave Club. Dollar Shave Club delivers amazing razors and grooming products for just a few bucks. Each razor was designed by a team of U.S. military engineers to provide maximum shavage while maintaining a gentle touch. By using our promo code Please give us an A on this project. We wasted our weekend on this video. You can get your first 3 months free and help support the team here at JFlex Productions. Anyways, back to the...
What? I want to shamelessly plug myself too. Hi, if you don't know who I am, I'm R Drizzle with the Sizzle. Tss. Have any of you bought your tickets yet? To what? Let me think. The gun show! That's what the tickets are for. If not, call me and I can hook you with front row seats and backstage passes. Be sure to use the code though. Seriously, please give us an A. I have a 79% in this class. To get 10% off your next purchase. Anyways, back to the lesson.
Hey, what's up? You already know who it is. It's your boy J Flex out here, and you already know how I feel about nuclear physics. Now, let me tell you a little something. This
Beep.
it's pretty boring, but nuclear physics, major impact on society. So, let's talk about that. So nuclear physics basically includes providing carbon-free emission energy with the use of nuclear power plants or fission reactors, which works by splitting uranium atoms for heat and converting the energy to electricity. Nuclear physics are allowed for innovation in medicine, which is very important. Without medicine, you can't do nothing. You gotta heal up, feel me? One of these innovations includes radiation treatment. Radiation treatment works by breaking the DNA inside cancer cells, essentially killing them off. These technologies would not have been possible without understanding nuclear physics, making this topic the best topic to talk about, because without this, none of the other topics in our class would be possible. If you're trying to disagree with me, then I don't want to see you around me anymore, you feel me? Because here at J Flex Productions, we don't do one thing, and that's produce. Oh, we stay flexing too, you heard?
Thanks, JFlex. And that concludes this lesson on nuclear physics. Tune in next year where we discuss how to perform brain surgeries on your friends and family. Make sure to hit that like button and subscribe if you have not done so. And as JFlex always says, stay flexing.
Bum 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 bum.